SQA National 5 Application Maths 2024 Paper 2 Mock Exam. Let's go. Question 1 says, Hampden Park's having a fan zone for people to watch tickets in Germany in June. 10,000 were sold for the fan zone. This increased by 12.5% a month on March and April. It's anticipated 1.7% will be returned in May as it can no longer attend. Calculate the number of tickets sold for the fan zone in May. So we've got 10,000 times 12.5%, 100 plus 12.5 divided by 100, 1.125. 2 months times, and it's 1.7 is returned, so you do 100 minus 1.7 divided by 100, 0.983. And that's just 1 month. So yeah, work that out in a calculator. And you get 12,441. But you have to round to 2 significant figures, so you're cutting here, so it's 12, just 1,000. And we're done there. Question 2. Dracania plants and 6 offices on the ground floor are as follows. This is a number. Calculate the mean and standard deviation. So mean means you add them all up and divide by how many you are. So mean, you add them up, that gives you 33, and there's 6 numbers. 33 divided by 6, and the calculator is 5.5. Now standard deviation I use the start of the exam paper, and it's the square root of x minus x bar squared over n minus 1. So I usually draw a little table with my x's, x minus x bar squared. So my x's go down the side, 10, 5 and 7, 2, 3 and 6. X minus x bar means you take away the mean each time. So you get your calculator out and you get 5.5 and you get minus 0.5 and 1.5, 2 minus 5.5. 2 minus 5.5 is minus 3.5, and then minus 2.5, and then finally 0.5. And then you square them. Now, a 9 is times a minus is a plus, so you just square the numbers. 4.5 gives you 20.25, 0.5 squared is 0.25, 1.5 is 2.25, 3.5 squared is 12.25, 2.5 squared is 6.25, and 0.5 squared is 0.25. And then you add them all up using a calculator and you get 41.5. So now your standard deviation is just the square root of 41.5 all over now 5, because it's one less number. So square root brackets 41.5 over 5, close the brackets, 2.88 roughly. And we're done there. The number of Dracania offices in the top floor is 6, so let's take a note of that. The number of Dracania plants in 6 offices in the top floor is 7. That's a mean number, so x bar equals 7, and the standard deviation of the top floor is 3.3. And we were on the bottom floor, remember, and we had a mean and a standard deviation. Also, our mean was 5.5 and 2.88. 5.5, 2.88, and it says make 2 value comparisons about the number of plants on the top and bottom floor. So using on average for the mean, there's more plants on the top floor. And that's because 7 is greater than 5.5. Now using our standard deviation, the number of plants on the top floor is more varied. And that's because 3.3 is greater than 2.88. And we're done there. Question 3, Abby earns $15.60 a month. National insurance is calculated before deductions, and it says calculate national insurance. So it says up to 10,480. 0. So we've got 0 for this one. From 10,480 up to a maximum of 14.89. 41.89 is 10%. Now she earns $15.60, so she's within there. So you do $15.60 minus the bottom number 10,480. And you're going to work out 10% of that times 10 divided by 100, or times 0.1. So you can do all that in a calculator. 1560 minus 1048 is 512 times 0.1 is 51.2, or £51.20. Part B. Abby pays 4.8% of her monthly salary into her pension, and her annual income tax is 1028.67. find her monthly net pay. So remember, her monthly pay is $15.60. Let's just take a note of that there. We've just worked out our national insurance for the month is $51.20. We've got our tax in this question is $1028.67, but that's per year. So I divide that by 12, make sure I don't skip that, to get her monthly. If you do that, you get $85.72. And then for her pension, it says 4.8%, so 4.8 divided by 100% times 1560, or times 0.048, and you'll get 85.72. You'll get 74.88. So now net pay means I take her gross pay, 1560, what she's paid, and take away all the numbers. Again, it's calculator job, so you just get your calculator out and take all of them away from 1560, and you get 1348.20. And we're done there. SQA National 5 Applications Maths 2024 Mock Paper 2. Amy is going to Giza. The details of Amy's journeys are below. Her flight leaves Edinburgh at 06:25, so let's take a note of that. That's Edinburgh. And arrives in London at 7:40 local time. So we're going to go to London first. So off to London we go. And we're arriving at 07:40. So we can work out how long does that take. 6:25, 7:25, that's an hour. And 25:35, that's 15 minutes, an hour 15. So we've done that one. I see she has stopped over 5 hours 15 minutes in London. So we're still in London. No journey. It's 5 hours 15. So let's see how long that takes us to. 7, 8, 9, 10, 11, 12. So that'll be 12, 40, 55. And we've done that one. She arrives in Giza at 16:55 local time, but also the next one says Giza's 1 hour ahead. So if I think of London time instead of Giza time in London, 18:55 minus 1 hour, 18 becomes 17:55. So it's really 17:55 looking at my own clock. And how long is that? Well, that is 5 hours, isn't it? 12, 13, 14, 15, 16, 17. So that's just a 5 hour. And it says calculate total flight time. So I need the flight times, 1 hour 15, plus that's not a flight time, I was just hanging about in London, 5 hours. So that equals 6 hours 15. And we're done there. Foreign exchange. Amy exchanged £1,000 to Egyptian pounds. And the exchange rate is £1 is 59.97 Egyptian. Amy is in Giza for 14 days and spends an average of 3,000 Egyptian pounds. Before transfer, she changes it back to British pounds, but won't accept multiples of 1,000. How many does she receive? So let's start off with 1,000, converting that into Egyptian, 59.97, timesing that together. So that's 59970. You can use a calculator for that. I'll just write egg pounds, Egypt pounds. Okay, she's in Giza for 14 days and spends 3,000 each day. So 3,000 times 14 is, using a calculator, 42,000. And then we'll just keep a note of that, still Egyptian pounds. So how much has she got left over then if she had 42,000 spent and 5,997? So left would be 59970 minus 42,000. Again, using a calculator, you get 17,970. And we're going to change them back, but we only take multiples of 1,000. So the most I can take back is 17,000 because I can't, 970 is less than 1,000. So I'll do 17,000 divided by the exchange rate to get back to pounds. So 17,000 divided by 59.97 is 283,475. So to the nearest penny or second decimal place, 283.48, and we're done there. Stem and leaf diagram below shows the prelim marks for a group of S4 pupils. It's split into two papers, calculator and non-calculator. Non-calculator left, calculator right. So a few things on stem and leaf. To read this, well, n equals 15 is just telling you there's 15 numbers here. 1 line 5 means 51. 6 line 0 means 60. Notice this is the middle part. The middle part's the tens, and the right or left side is the units. So let's read this. 3 and 0 is 30, or 5 and 3 is 53. State the highest number of marks achieved across both papers. So the highest unit is tens is 5, 53, 59, 59 is the answer. A modal score in a non-calculator paper. Modal score, that's just mode, it means. Mode is the most common. So I look at the non-calculator paper and see if there's any, well, that's just one of each of the tens, one of each of them, one of each of them. Then I've got 40, 40, 1, 2, 7, 3, 0, 3. 40 is the mode because 40 appears twice. Determine the difference in the median scores in each paper. So median is one in the middle. So I need to find the middle of each of them. So let's look at non-calc and calc first of all. Now there's 15 in each. So that means that the middle one will be the 7th number, because if I've got 6 either side, 6 and 12 plus. So since I've got 15, to find where the middle one appears, I can say 15 plus 1 is 16, divided by 2, it's the 8th number of each. So just counting the left hand side, I've got 1, 2, 3, 4, 5, 6, 7, 8, 36. In the calculator, 1, 2, 3, 4, 5, 6, 7, 8, 29. So I'm identifying the 36 and the 29. This will find the difference. 36 minus 29 equals 7. And we're done there. Question 6. Michael flies his drone for 400 metres on a bearing of 55 degrees. He then flies it for 500 metres on a bearing of 190. Construct a scale drone. So 1 centimetre is 50 metres, it says. So let's just get started with our first knot point where Michael is. It's 55 degree bearing. So you always go north and you go to the right clockwise. So I've already done that there. So we've got 55. So we're going round to 50 on the outside and 5. So it's there. You just mark your point and then you join it up with a straight line. My 0 on my ruler, which will be more obvious on yours. And I need 8 centimetres, which for me is way up here. But that's fine. I knew that would happen on this bit of paper, so I'll just try and join it up as best I can. Mine will be a slightly inaccurate because I'm using an iPad, but you get the idea. I get a picture like that. So now it says, if n does 500 metres on a bearing of 190. So 500 divided by 50 is equal to 10 centimetres, and his bearing is 190 degrees. So again, I get my protractor, but the first thing I do is draw a north line. So over here, I draw a line going straight up, and that's north. But since I'm going over 180, I'm actually going to have to go down the way as well. And that's because if I measure round with a normal protractor, if you've got a better one, then fine. But a normal protractor only goes to 180. So I'm going to have to actually go an extra little bit. So to work that extra little bit out, it's 180 plus 10 is 190. So I need a 10 degree angle on the left. So let's get the protractor and show you that. Zoom in a little bit. But since all the way round to the right is 180, I need to turn my protractor upside down to go to the left. And I'm going to measure down the way from the centre. Measuring it up as best I can, turning it round a little bit. But 10 degrees is about there for me. But again, I'll be quite inaccurate because I'm using an iPad, so you just try your best to be as accurate as you possibly can. And we worked out that was going to be 10 centimetres, so you get your ruler again, line it up from your centre, remember, always starting from your centre. As you draw back to where you stand, and you just scale draw to determine the distance and bearing of the sun journey. Now mine is not very accurate because I couldn't actually get a line 10 centimetres, but basically you just join up your start and end points, you draw a north line in. So there's my north line, and you would do how far round that is. So I might need to actually go under there. So in actual fact, I need that angle. The inside scale, so that is about 75 degrees, I would say that is. With that protractor again, you'll be a way more accurate than me, but I'm just going to say 75 degrees here. So that's 180 plus 75. Which is 225 degrees. And then I measure the length of this line. So let me just get the ruler and finish this off for you. So for my one, I get about 6.5 centimetres for this line. But again, mine's is going to be wildly inaccurate because of the fact that I'm using an iPad here. But let's just say that's what it is. So the bearing is 225 degrees. I've got 6.5 centimetres, but remember I need to times that by 50 because that was what I started with as my scale. So 6.5 times 50 is 325 metres. And that'll be me done there. But remember, if you do this question yourself, your answer will be way more accurate than that because I'm way off based on the fact that I'm using an iPad here. But you get the idea, hopefully, rather than anything else. Company sells Dracaena plants. To transport, they put in small boxes. Then packed it in the larger box. They must be stored upright. Calculating maximum number. So this is your box packing question. But this time, this one here cannot be changed. So I'll just take a note of that. Check my units. 1.5, that's 150 centimetres. And 120. I usually just do this in a table. So the table I'm looking at is option 1. I'm going to look at my height, which can't be fixed, against my length and my breadth. Let's just call that length and breadth, just so you've got it. And what you're going to do is your height, you're going to do big divided by small every single time. So I'm going to do 70 divided by 30 for option 1. And then my lengths, 150 divided by 20. And then my breadth, 120 divided by 25. And then I'll have an option 2 because although that one doesn't change, that stays the same, you can switch out your length and breadths against each other. So the 150 and the big ones stay the same, and the 20 becomes 25 here and 20 here. And now you'll see if I try and switch any more, I'm just going to get back to the same position because the height is not allowed to change. So you do your division sums, but remember you round down because this is real things, so you can't actually round up. So you get your calculator, taking your time, 70 divided by 30, 2.33, and then I just say that's 2. 150 divided by 20, 7.5, so that's just 7. 120 divided by 25, 4.8, so that's just 4. Do the same on the other side. I already know 70 divided by 30 is 2.33, so that's just 2. 150 divided by 25 is 6 exactly. 120 divided by 20 is also 6 exactly. So to get your number, you do the numbers times together for each option. 2 times 7 times 4, 2 times 6 times 6. So for the first option, 2 times 7 times 4 is 56. And the second option, 2 times 6 times 6 is 72. I pick a bigger number. So 72 is my max. So I just write that max equals 72, and we're done there. The big one is the tallest roller coaster in the UK at Blackpool Pleasure Beach. At its highest point, the big one is 235 feet above sea level, and after the first drop, it's 30 feet above sea level. The horizontal distance is 440 feet. Find the gradient of the first drop. So imagine this, and there's 235 up here is how high it is, but after the second one, it's 30 foot still above. So I need to know the difference between these two numbers for my height. So that's the trick with this question. So it's actually 205. And then gradient is vertical over horizontal from start exam paper. The horizontal is 440. So my gradient is just 205 over 440. And you can just use a calculator to change that to a decimal if you want, or simplify it. 205 over 440 though. If you need to, I can divide by 5. It's 41, and then 440 is 88. I mean, I don't think there's any other numbers that go into both of them, so I'll just leave it there. Okay, a local boys brigade company is raising money for the trip to Glasgow by making candle holders. We make 75, the total cost is 105.50. 20 members are travelling to Blackpool Beach, and the cost per member is 34. Calculate the minimum price that should be charged for each candle. So it costs them 105 to make it, so I need to work out how much it costs to go to Blackpool. So to go to Blackpool, it's 20 times 34. That could be non-calculator, but since I'm in a calculator paper, why not? So that's £680 to go to Blackpool. So total costs are £680 plus £105.50. That's £785.50. So that means that since I'm making 75, I can just do 785.50 divided by 75. That gives me 10.473. Now, in this case, I actually want to round up. This is a bit of a weird one, this, because if you think about it, I want to make the money to actually get to Blackpool. If I round down, I'll be short by pennies over for every single sale. So the minimum cost is a round up on this one. So it's £10.48. But don't worry too much about your rounding if you're unsure about that. The giveaway traffic sign shown below, it's the shape of a triangle. Calculate the height of the sign. So this is a Pythagoras question because the height is going to be a vertical line from the corner up the way. So I draw a right angle. So for Pythagoras, I need two numbers. So I've got 1.25, so I can divide that by 2 to say that that is 0.625 here. And I want my height. I'll just call that A. So remember, from the start of exam paper, A squared plus B squared equals C squared. And a lot of people think you need to add, but you only add when you find the long side. C is the long side. If I find one of the shorter sides, and I know that's the long because it's opposite the right angle, I take away. So to get A, I do the square root of 3.8 squared minus 0.625 squared. So that's the square root. You can do that all in one go in a calculator, just using brackets. 3.8 squared minus 0.625 squared, square rooted, is 3.748. Or about 3.75 metres. And we're done there. Part B. 500 litres of white paint are required to renew 60 giveaway signs in the town. Calculate the volume of paint required to renew 550 giveaway signs. So, it looks like a volume question, but it's actually a proportion question because it says 60 signs is equal to 500 litres. And I want to get to 150 signs. So how am I going to do that? Well, first of all, in the middle, I'm going to do one sign. So that's 500 divided by 60. And that means that for 150 signs is 500 divided by 60 times 150, which you can just do in one go in a calculator. If you do it in separate steps, make sure you keep 8.33, don't round it too much, times 150, and you get 1250 litres. And we're done there. Diagram shows a new storage box in the shape of a treasure chest, and it's a cuboid and half a cylinder. So the diameter of the cylinder is 50, calculate the volume in litres. So let's draw this out. We've got a cuboid. So there's like my cuboid part with basically a half a cylinder on top. So looking at our cuboid, it goes 50 that way, 90 that way, but the height is not 60 because from here to here is the radius. Now, what is the radius? The radius is half of 50, which is 25. So if I do 60 minus 25, I get 60, 50, 40, 35. So that means the height of the cuboid is 35. The radius of this one is 25, and the length along here is 90. So our volume is just 50 times 90 times 35 for this, plus my half a cylinder, well that's a half, times pi r squared, pi times 25 squared times 90. So efficient use of a calculator, 50 times 90 times 35 plus 0.5 times pi times 25 squared times 90 is 245857.293 centimetres cubed. Now, one thing to know, we want this in litres. 1 centimetre cubed is 1 millilitre, so which means that 1 litre, which is 1,000, equals 1,000 centimetres cubes. So if 1 litre is 1,000, I can divide by 1,000 my answer just to get it into litres. So that equals 245.86 roughly litres, and we're done there. These are transported by a lorry from a factory to a storage facility 60 miles away. The lorry travels a speed of 50 miles per hour. The storage facility closes at 5 and they're encouraged to leave 45 minutes earlier than planned due to roadworks. Determine the latest time the driver should leave to ensure they travel before the storage facility arrives. So we've got a distance and a speed. So time is distance divided by speed, because distance is speed times time. So the distance is 60 miles and it's 50 miles per hour. So 60 divided by 50 is 1.2 hours. But we want hours and minutes. So that's 1 hour. Now 0.2, 60 minutes times 60, 12 min. So it takes 1 hour, 12 min to get there. The storage facility closes at 5. We need to leave 45 minutes earlier than planned. So let's start off at 5 o'clock. Let's take away the hour. That's 4 o'clock. Take away the 12 minutes. So that's going to get me to 15:48. And then take away the 45 minutes for the roadworks. That's 15:48 becomes 08, becomes 03. 15:03 or 3:03. And we're done there. Question 10, National 5 Applications in Maths 2024, Paper 2, mock paper of course. In the game Dungeons and Dragons, my favourite game actually, players roll various dice during a turn which impacts how the game progresses. To succeed in a turn, a player must roll a greater than 9 on a d20, which is a 20-sided dice, so numbers 1 to 20. A total of less than 8 when rolling 2 6-sided dice at the same time. Determine which dice roll has a higher probability of being successful on their turn. So, let's look at the 20-sided dice first. d20, that's just a single thing, so greater than 9. So I want the probability of something happening which is bigger than 9. So how many numbers are bigger than 9 on a 20-sided dice? Well, let's just count it. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 11. And there's 20 numbers in total, so 11 out of 20. Now we can change that to a decimal if we need to, because we're going to have to compare. So we can just get a calculator. 11 out of 20 is 0.55. So that one's easy. But now let's look at the D6. It's 2 we're rolling, so we draw a little table. 1, 2, 3, 4, 5, 6, because 2 things are happening. 1, 2, 3, 4, 5, 6. And it says, what do we do with these? Total, we're adding. So we'll just add each of these together. So 1 plus 1 is 2, then we get 3, 4, 5, 6, 7. And then 2 plus 1 is 3, then we get 4, 5, 6, 7, 8. 3 plus 1 is 4, you get the idea. 5, 6, 7, 8, 9. I'm just adding. 4 and 1 is 5, 4 and 2 is 6, 7, 8, 9, 10, and so on. We get 6, 7, 8, 9, 10, 11, and then finally 7, 8, 9, 10, 11, 12. And if it said times, you would times and so on. And then it says we want a total of less than 8. So how many of these are less than 8? Well, we can just check that by counting. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 are less than 8. So on the D6s, we've got 21 out of how many is there? 6 by 6. 6 times 6, 36, or count them. So it's 21 out of 36, which is 0.583. So which dice roll has a higher probability of being successful in the turn? We just write down the answer. It is the D6. And we're done there. Because that's bigger. And does it say give a reason? Yes, because 0.583 is bigger, greater than 0.55. So there's my answer. Okay, next question. Many players decide a character to start with Dungeons & Dragons game using a randomizer. Players roll 2 multicolored dice to decide their character. Red, yellow, green, blue, red, yellow, green, blue. Carol rolls 2 dice and his character is an elf. State the possible rolls he must have made. Okay, let's see where the elves are in here. So there's an elf. Just an elf, not a half elf then. There's an elf. So to be an elf, he could have done red and green. Red and green. So red and green. Or to be an elf, he could have done blue and yellow. Blue and yellow. Is there any more options? I don't think there is, so we're done there.